Good afternoon. We are Sangmin Kim and Doyoon Kim. The subject of our capstone design is effective continuous testing with automated unit test generation technique. Unit testing is important in software development. Unit testing could detect and prevent possible bugs in the software. However, it takes a lot of effort for engineers to make effective unit tests. This is why automated unit test generators were introduced. However, these tools produce too many false alarms and they can distract the engineers from discovering actual bugs among them. To solve this problem, we have designed a system called CTG Randub. CTG Randub aims to automate the process of generating unit tests with Randub and then filtering the possible false alarms to the user. This way, when the engineer makes a change to the code and receives the output, there will be far less errors the engineer needs to revise. But how can we determine the false alarms? There is actually no way for a program to automatically determine false alarms of the project. So we refer to the error revealing test generated by Randub in the previous version. If the same error occurs in the previous version and the current version, we assume that the engineer didn't fix it on purpose, so conclude that this is a false alarm. This is the outline of CTG Randub. First, the engineer prepares the target repository for the automatic part of the system. Secondly, after the engineer is done, the rest of the jobs are handed to the CI manager. So, when a new test version is created in the test repository, CI manager performs unit test generation and stores the information about the new version to the test result database. In our project, we have used Jenkins as the CI manager. Thirdly, the unit test generator module automatically generates unit tests with the information in the test version. The unit test results that have generated test failures are sent to the fourth step, the filtering module.
The filtering module aims to filter out false alarms. In other words, the same errors that occurred in the previous version. The key of these heuristics is how to determine which errors are the same. We used 3 different criteria to determine this. The first criterion is matching error messages with just the exception type or exception type and the description. The second criterion is matching with full stack trace, topmost stack trace, or none at all. The last criterion is matching stack trace with line number or no line number. With combination of these criteria, we had made 10 different heuristics to filter error-revealing unit test outputs. We have conducted an experiment with our system to 6 bug cases from several open source repositories such as JSoup, Codec, YodaTime, and Gsin. These bugs are included in Defects4j, a collection of reproducible bugs in Java projects. This chart shows results of our experiment. Rows indicate different bug cases, and columns show the number of possible bugs after the filtering process. The results show that our system can detect real bugs while removing up to 66% of false alarms. Furthermore, it can be concluded that the fourth heuristic that matches error messages with exception type and description, topmost stack trace with no line number, produces the best result, removing most false alarms while catching all the bugs. With this experiment, we have submitted a paper to the Korean Software Congress. Thank you for listening.